pretty good handle on what we're looking at here to try and figure out how to write an equation given a slope and given a point. So this last example, just a reminder, what's the first thing we need to find again? Your slope, and then after that, you get your values plugged in, you're working your way towards slope-intercept form, and you've got a good model there. So here's what we want to do then. I want you to flip the page. When you flip the page, get to the top of this page right here. Same game here in example 3. Our job, simply put, write a linear function f with values f of 8 equal -1 and f of 6 equals 0. Anytime we've had function notation, we've said change those to a change them into what? F or a point. So what would you call f of 8 equal -1? What comma what? 8 -1, okay? And then what's the other going to be here? Exactly, 6 comma 0. Okay? So what I'd like you guys to do is this. I'd like you to use those 2 points right there to identify your slope, get a point in there. I'd like you to use your point slope formula to write an equation in slope intercept form here. So take a few minutes at your table, work with your partner on this. If you have questions, check with your partner, check with your peer on this. I'll be your partner. Okay? Hey, you've always heard it. If you disagree about an answer, make sure you talk about why you disagree. So go ahead, see what you come up with here. And then what I want you to do afterwards, you might make sure you're correct, confirm that you're correct. Okay? So example 3, get that done.
C6 equals 0. So
Am I doing it right?
Let me see.
0 -1. Okay, how about this right here? So what kind of value do you have
And then you put the numbers in
Positive.
for
So what's that mean? So positive, then negative would be.
Yeah,
So it's -1, so you're on your way, okay?
-1
Got it? Good stuff. Check someone around you, all right?
y minus 1 word n something something something. That's your slope. That's what I just got the slope. Yep.
I want to
more time we need out there right now.
I think I know what it is.
I'm gonna have a solution right now, give me a show of hands on that. Righty then. Let me look at your slope. So you guys agree on slope, I like the slope, okay? Yes, however, the one thing I do not like, go to your distribution part where you still have parentheses.
Yeah.
What did you distribute with, what value? Negative 1/2, right? Don't you have a negative 1/2?
Oh.
The only thing I'm concerned about is here and what kind of, yeah, you should have negative half x, but what's negative half times negative 8 right there? It's a negative times negative, so plus 4 is great. That step right there, instead of minus 8, what should you have there? There you go. And then you'll be on your way, okay? Really close. Why do you have 6 here? Put negative 1 in here. So if you use a negative 1 from that point, you would have to use, change that to an 8 and then fix your correct. There's your, okay? Nope, you're right on track. Keith. Supposed to become y plus 1. What's a negative times negative? That's all right. So what are you gonna do?
Oh.
Tell me you got that. There you go. Very good. Very good.
I think that's.
Okay, let me give you about 30 seconds or so. 11 here. So you like negative times negative. Everything looks great now. Love it.
But I finished it without my partner.
All right, let's look at this here in a second, okay? So close. This should be x minus 8 right there. So close, okay? But you're on the right track. We're gonna clean a few things up here quickly, all right? Okay, you guys help me out here. What's the first thing we need to think about finding? Slope, okay, so Devin, help me. Formula-wise, we should know the formula by now, so help me fill in the appropriate values. Zero minus negative 1. Yep, make sure you speak loudly too so Mrs. Olson can hear you. And then how about the bottom? 6 minus 8. So we end up with, help me out here. You guys agree 1 over negative 2?
Yeah.
So what's that make my slope value? Negative 1/2. I would agree with that, okay? Give me a show of hands. How many had negative 1/2 on the slope? Okay, and that looked really good. As I was walking around, looked really good. All right, so this idea now of point slope form. We know our slope right here, negative 1/2. Guys, which point do you want to use? First one or second one? Use the first one. So we'll use 8, negative 1. And that's the beauty about this. It doesn't matter which point you choose to use. Choose one of them. Okay? All right. Who wants to start this out for me in point slope form then? What's my first line going to be? Knowing my slope's negative 1/2 through the point 8, negative 1. What's that first line going to look like? Write an equation in point slope form. Oh, come on, don't be shy. Sam, have you got that first line?
Y minus negative 1.
Yep, y minus the y value of negative 1.
Equals negative 1/2, and then parentheses x minus 8.
Very good. Okay, so that would be point slope form. That would be our start. So now we just want to manipulate this to get y alone. Okay? Right here, subtraction of a negative, same as adding, right? So what are you going to change the left side to? Y.
Plus one.
Yep. Help me distribute down the right. Negative half in x. Negative 1/2 x. And then negative half times negative 8 would be, careful on this, a lot of people got caught on this. Negative times negative. Plus how much, kiddos? Okay, so to establish y alone in slope-intercept form at the end, what do you have? What are you going to have? Negative half x plus 3, okay? Now, let me ask this question. How would I know that that's correct? What can I do?
That's one.
Run to decimals. Tell me what to do here in decimals, Chris. We think y equals negative half x plus 3 is the right one. We want f of 8 to equal negative 1, f of 6 to be 0. In other words, pass through these 2 points up here. So you're telling me to go to decimals. Okay? Tell me what to type in.
Where's it going?
Y equals
negative half of x.
okay,
Plus
plus how much?
5. 3.
There you go. Okay, now screenshot this right here.
Oh, yeah.
Which 2 points did we have to pass through? 0, 6. Let me go find 0, 6 on the graph. Or was it 6, 0? 0, 6 or 6, 0? 6, 0, so that'll be right 6. Oh! Does our solution pass through the given point first there? Does. How about my next point? What was that? So right 8 and down 1. Are we right? Yeah, you know you're right because the equation you came up with passes through the 2 given points. You know you're right. Okay? All right, so the last thing I'm going to hit here then is on the real life example here. I think you guys have got a pretty good understanding. Again, are there going to be times where you make a mistake with the arithmetic? It's going to happen. Okay, it's going to happen. But just like we did here, when I got a solution, you might want to plug your solution in there and see, hey, does it go through the specified points that they wanted me to travel through? Here we've confirmed that we know we're right here, don't we? How many got caught on the negative times the negative part? Okay, happens. Okay, I would say check your solutions in decimals when you're done with it. All right, let's roll on to this last example here today. I like this problem. Solving real life problems. I'm going to read this. It says to ride in a best-in-town taxi, you pay a starting fee and a mileage fee. Okay? It says the table shows a total cost of a taxi ride for different distances. First question they want us to answer is this. Can this situation be modeled by a linear equation? In other words, is the information down here, does this table model something that's linear? Okay? Chris, I'm going to pick on you. You use the one phrase the one day. What are we looking for to know if this is linear?
Constant rate of change.
A constant rate of change. Very good. Okay? Constant rate of change. So you guys help me with this. Let's do change in y's. Our cost is represented by y. Distance is represented by x. Help me with this. This first change in y, how much do you have here, kids? 10. From 13 up to 23, change to 10. 4 up to 8. Changes how much?
2.
Ah,
4.
change of 4, right? So that first change is 10 over 4, right? First rate of change is 10 over 4. Next one, 23 to 28, where you at? How much change? How much change in x from 8 to 10? 2. Now guys, are these two rates of change the same? I'm hearing no, but I'm hearing yes.
Yeah, they are.
They are the same. What 10 over 4 reduced to
5 over 2.
5 over 2? Okay, very good, Devin. Very good. Okay, then this next one, 28 to 33. Change of 5, 10 to 12, change of 2. What's that rate of change? What over what again? 5/2. Okay, all of these are equal, 5/2. So the question up there, can this situation be modeled by a linear equation? What are you gonna say? Can this be modeled linearly? Yes, it can be. The reason it's linear, what's our reason? Linear because, Chris, how should I fill that in again? Because the rate of change is the same. My slope, 10/4 reduces to 5/2, 5/2. All of those rates of change, those fractions are all equivalent. So I'm gonna say yes because there is a consistent rate of change, consistent rate of change. Guys, if you took 10 divided by 4, or 5 divided by 2, what is 5 divided by 2? 2.5. All of those would be 2.5. So my rate of change is this. I change 2.5 in y for every x value of 1. So here's what we're looking at, guys. Rate of change right here, simply again, like we've talked about in the past, is the same as our slope. So what is our slope for this problem right here? Let's leave it in decimal form. What'd you say 5/2 was again, Sam? 2.5. Okay. So that first question up there in green, can the situation be modeled by a linear equation? We say absolutely it can be because all of the rates of change are consistent. They would all divide out to be 2.5. Now, we know that it's possible, so our job now is to write a linear model that represents the cost as a function of the number of miles. We need a point and we need a slope. Do we have the slope already? Okay, slope's 2.5. How many points do you actually have up there? 1, 2, 3, 4. Which point you want to use, guys? Does it matter? No, doesn't. Okay, let's just pick 8,23. Stay with me here quickly. We're going to finish up. 823. Let's jump into point slope form. We're going to use 8 as my x1 value, 23 as my y1 value. So help me fill this in, knowing my slope is 2.5. Here we go. The model that we come up with this to represent the cost as a function of the number of miles is as follows. We're going to go y minus how much? Y minus 23 equals my slope value of 2.5. How about my quantity? What minus what? X minus 8. You guys quickly get this worked out so that y is alone. Give me an equation in slope-intercept form, and we'll pick this up a little bit tomorrow. Tell me what you get when y is alone here. All right, run out of time here. Just got a slope-intercept form value for me. Got it, Jasmine?
Y equals 5/2x plus 3.
And I'm going to call this 2.5x, same thing, plus 3. Okay? Hey guys, if I had to ask this question, we've gotten this down to the slope-intercept form, which is correct, by the way, and we'll look forward. Hang on 1 second here. What would the starting fee be in this right here? $3. Jump to the cap, $3, and then how much is each additional mile going to cost you? $2.50. All right. Talk to you later.